Hello and welcome back to Math 8. This is a video over Unit 1, Section 2, and what we're going to be doing in this section is we're going to be interpreting graphs. And we're going to be analyzing qualitative graphs. We're going to interpret information given a graph, and we're going to create a graph to model a situation. So the first thing we want to talk about is a qualitative graph. So over here we have a definition. A qualitative graph expresses the important characteristics of a situation that does not necessarily have numerical values in a visual form. So, qualitative means without numbers. Okay, so it's a graph that is with no numbers. Okay, and here's an example of a graph with no numbers. Okay, in this hypothetical situation, what we have is we have a skier goes up a mountain at a steady pace, and then the skier skis downhill. So what we have here, our x-axis is time, our y-axis is speed, how fast they're going. Now, right here, I know that the speed is constant. So this part right here is constant speed. Okay? And that's for this part of the graph, okay? Then all of a sudden, the graph starts to go up. And what happens is their speed is increasing, okay? And what we know is that increases because it's going up, okay? And what we know about this, guys, is that, when you ride up if you're going skiing, skier goes up the mountain at a steady pace. When you get on the lift, you're going at a constant speed. There are times that you stop and they've got to fix something because somebody at the bottom of the hill screwed up. But, okay, once you start going down, you start to gain more speed, okay? And so as time goes on, you're traveling at a constant speed, and then you speed up as you ski down the hill. So this is a qualitative graph because it doesn't have any numbers. I don't know how fast we're going. I don't know how much speed we gain, but this is a situation where we are just describing this situation with a graph, okay? So let's practice that and actually graph a situation. So in this situation, what you have is you have the speed of a train is tracked as it stops at stations along its route. So here's time, and then we're going to talk about the speed. Now let's think about something here, okay? When a train goes in between stops, okay, it starts at a speed of 0. Okay? Okay? Then, so that's the first thing it does. The second thing that it does is the train speeds up. Okay? And when it approaches a station, it slows down. Okay, and then when it reaches the station, it stops, and then it repeats, okay, from station to station. Okay, and so what we can do is we can model this, all right? So what I'm going to do is just kind of think of a generic situation where this would happen, and what's going to happen is we're going to speed up, okay, reach a and let's do this. Let's speed up here, reach a constant speed, slow down to a stop. It's going to sit at that spot for a few minutes. It's going to speed up again. It's going to reach a constant speed for a while. It's going to then slow down and then stop to pick people up and let people off. And that process is going to repeat, okay? And so what I want us to do is just, kind of describe this. So, this part of the graph is where it speeds up, okay? This is when it's going at a constant rate, so a constant rate. All right. This next part is where it slows down. Okay. And then we have this part of the graph where it lets people on and off. So people get on/off the train. Okay. Now, is this is this a perfect graph? Is this an extremely accurate graph as to a situation? But no. But all I'm doing is I'm taking the situation of the speed of a train is tracked as it stops at stations along its route. Okay. So we have to think about what a train does and then model that over here. Okay. All right, so we have a couple of different types of graphs. We have a continuous graph and we have a discrete graph, okay? A continuous graph is a graph of coordinate plane made up of lines or curves with no breaks. So one thing I think of when I think of a continuous graph is graphing without picking up the pencil. Picking up the pencil. Okay? So, you know, a continuous graph made up of lines or curves with no breaks means that I'm just going to graph a curve like this. All right, I'll put arrows on it, and this is just a curvy graph. These curvy graphs exist, but it's continuous because it has no breaks, okay? All right, so I drew this whole thing without lifting my pencil. Okay, now a discrete graph is a graph that has a finite or limited number of data points. So a discrete graph has breaks, okay? Means you have to lift your pencil to make the graph. Okay, so a discrete graph would look something like this, where you just have a series of data points that go across the graph like so. Okay, and these kinds of situations are modeled all the time. We just may not think about it. Okay, so let's talk about this. Are these graphs discrete or continuous? All right, so let's go through these problems and let's answer them. So what I would do is I would pause this video, try these problems out first, and then see if you get them right. So I'll give you a couple of seconds to do that. All right, so the answers to this is a discrete graph because it's a set of points. Okay, this is continuous. Continuous. This is discrete. Oh, sorry, continuous. Continuous. And then this one is discrete. Okay, so check to see if you got those right. Pretty self-explanatory. All right, let's move on to the next page. All right, so let's use this information here to create this graph on the next page. What it says is the table shows the altitude of a plane as measured each minute after it begins its descent. The data is reflected in the graph, and we're going to ask, why is the line continuous based on these data points? So let's go ahead and just plot these data points on the graph, okay? So what I know is that at time 0, okay, time is our x-axis, altitude in feet is our y-axis, okay? And when the plane is in its descent, that means that it's going down, all right? So at time 0, we're at 20,000 feet, okay? So we begin our descent, and I'm going to do this in red, okay? We're at 20,000 feet. After 5 minutes, we're at 15,000 feet. At 10 minutes, we're at 10,000 feet. And then all of a sudden at 20 minutes, we are at 0 feet. Okay, this is the point where we land because our altitude is 0. Okay, so land the plane. Okay, and this part here is where we begin our descent. All right, so the question is, descent, is it? D-E-S-C-E-N-T. S-C-E-N-T. Okay, so the question is, why is this line continuous? Now, let's think about this, all right? In between, you know, what's happening at each of these points? Okay, do I draw a line? Not do I draw a line, I'm going to draw a line going down. Okay, how come this is continuous? All right, and the reason is this. Okay, and I'm going to write this. The graph is continuous. Continuous because in between 0 and 5 minutes, the plane is constantly losing altitude. Okay? You know, the thing of it is that when you guys are in a plane, you're going to have to pass through, you know, if our data points from between 0 and 20,000, 0 minutes, 20,000 feet, and then 5 minutes and 15,000 feet, we're going to have to pass through all those other altitude points to get to 15,000. That's why we have this graph here that goes through all those points. That's why it's continuous, okay? Because when you think about it, if you're just going to sit in a plane, you know, you don't just automatically go, all right, I'm at 20,000 feet, and we're going to stay at 20,000 feet and then just immediately drop down to 15,000 feet. So this graph is continuous because, you know, we're constantly losing altitude as time goes on, okay? Now let's take a look at the next one. Okay, this one says printing photos at a grocery store costs 90 cents per 5x7. Graph the relationship of the number of photos to the cost. So if I have one photo, it's going to cost me 90 cents. If I have two photos, that means it's going to cost me an extra 90 cents. So I need to add 90 cents to that. That's going to be $1.80. Okay, so 1.80. If I have three, I'm going to tack on another 90 cents. Okay, and that's going to give me $2.70. And if I have four photos, that's going to give me $3.60. So one photo, okay, is going to cost me $0.9. All right, 90 cents. Use red here. Okay. Now, after two photos, it's going to be $1.80. After three photos, $2.70. And after four photos, it's going to be $3.60. Now, the question is do I draw a line through here? And the answer to that is no. This is discrete. Okay, this is a discrete graph because you can't buy part of a photo, okay? You can't buy parts of a photo, all right? It only gives you certain values that you can graph on there, okay? You only can graph, you know, one photo, two photos, three photos, four photos, five photos, okay? And so because you can't buy parts of a photo, I can't buy 1.5 photos, so there's no points in between here and here. All my data points are just going to be these data points on the graph. Okay, so hopefully that lets you see the difference between a continuous graph and a discrete graph and why some of them are continuous and some of them are discrete. So it kind of just depends on your situation. So go ahead and get started on your work, and we'll see you soon. Thanks a lot. Bye.